Hello, hello, hello. Am I live? I'm live. Alright. Welcome in. I am back to work on my game engine. I have been for the last couple of weeks streaming on weekdays, but I skipped yesterday. But yesterday I actually got a fair amount of work done. So when we left off, we had been working on a refactor, which was kind of critical for getting rid of some real complications arising from setting up my systems as classes instead of doing the proper thing and actually making them namespaces so that they're not in monolithic headers and things like that. And the problem that triggered me going to fix this was needing tighter integration between the editor and the engine layer for the sake of editing scene files. I realized that I needed to have access to private data that's in the engine layer and vice versa without exposing it to the game layer. Let me get my temperatures going. It's still a very hot summer, so I gotta monitor my CPU temps. Alright. Haven't looked at this on Windows for a little bit. I also, offline yesterday, I took and built it on Mac and fixed some of the problems that arose from the refactor on Mac OS. Not everything is working on Mac OS. I still have to implement a few things, particularly things involving the frame buffers. The viewport API and things like that. But at least it compiles. Anyway, so we have this scene where right now we've loaded up the test game project, which is a very bare bones test game, which I've added a click and drag move and then keyboard and mouse move. And if I plug my gamepad in, might as well just leave it plugged in, but I keep unplugging it. Here we go. If I have my gamepad plugged in, it responds to gamepad input, so on. And then inside the editor, we can take and we have this very simple transform going on. Now, just to review the problem that I was trying to resolve, this is sprite 1, creatively named. We have the ability to translate it using the XYZ. We have the ability to scale it in whatever direction we want. Z doesn't apply to a flat thing, but I can also scale in Z. And then we got the rotation, so we get the pitch, we got the roll, in the wrong order, I think, and we have the yaw, and this is where problems start. The way that this implementation works is that every frame, whenever we change the value from the inspector, we translate that into the quaternion representation, and that gets sent to the game engine layer and actually is assigned to the rotation of the entity. Excuse me, I had a late start today and my brain is still waking up. And then when we go to draw the inspector on the following frame, it takes the rotation from the game layer, translates it back into Euler angles, and displays it in the inspector. So one consequence of that, as you can see here, is that the rotation values wrap around. That's not necessarily a bad thing in and of itself, because as you can see, I can still get pretty smooth rotation movement from setting the rotation this way. It wraps around smoothly in the inspector, but it also is a smooth circular motion inside of the viewport. However, there's a problem with ambiguity when we start to use the third axis, and you'll see it start to flicker around when I do this. There's actually two orientations in Euler angles that can lead to this position. There's the basic one where these values are near zero, specifically that the roll value is near zero. And then there's the opposite, where these are subtracted by 360 degrees. Or sorry, 180 degrees. So we have a flip bidirectionally on both of the other axes. And so when we go to translate to and from the Euler angles every frame, GLM, which we're using to do the mathematics, the mathematical translation here, GLM doesn't have the information it needs to determine which version of the rotation we're using. There's an ambiguity there. So I think this is, I don't know if this has a proper name. It's like the opposite of gimbal lock. Gimbal lock is like where you lose a degree of motion or a degree of freedom after you've set two values to be equal to each other. In this case, 0 or negative 180 or something along those lines. So it's a little confusing to me if there's a mathematical term. I'm not a mathematician, but the problem can be resolved by kind of separating out what we do in the inspector from the actual under the hood representation of the entities. We had last week sometime reviewed how Unity handles this. Unity has just been a great UX exploration. If I go to open, I'm gonna leave my project for a second and go into my simple Unity projects. And if I go to one of its assets, project, environment, oh wait, no, that'd be scenes here. If I go into a simple scene like this one where I was testing my Win system, and we open it up in a text editor because this is YAML, we actually identified that the rotation is stored in two different places, and I think this is the scheme that I'm going to use. So in Unity, for the rest of the stream, I'll just leave Unity open as soon as I can get the project to load. In Unity, when you go to change the Euler position inside of the inspector, you are actually setting this value. This value translates into the actual rotation, which is a quaternion representation like this. But that doesn't go two ways. You don't translate it to Euler and then have it translate back and inform the inspector. The inspector just always shows this view. And then in game code, if you have the game code update the rotation of an object, then that at that time translates back into the Euler angles. And it does something weird too. Like in our experiments with physics, we had set up a rock with a physics body, and we had it fall and roll around on the ground. And we observed in the editor, and it's going to take forever to load Unity to show you this again. But we had observed in the editor that it doesn't actually revert back to the negative 180 range. If we set up 420 degrees as the rotation about the y-axis, which would be our pitch, sorry, not our pitch, our yaw, it doesn't translate back into a range within the first 360 degrees. It actually does hang out around the range that you had set up in the inspector. I'm not really clear as to how or why they would do that. My feeling is that if you were updating the Euler rotation from the code, there's a little reason not to clamp it to the local 360 degree range. But I don't know. Later on, if we decide that there's reason to do that, then we'll come back to it. But my plan for today is to add a section to our scene file, which is much simpler. Here. To add a section to our scene file, which has the Euler rotation hint, similar to what we saw inside of the Unity item. And then when we go to set in the inspector, there's a separate representation for the Euler rotation for every entity in the scene. And we update that from the game code when the game is running, and so we can see the Euler rotation inside the inspector while things are rolling about in the scene. And then when we go to change the rotation, it will not give us that gimbal lock thing where it flickers around when we get to the wrong axis. And while we're doing this, we may as well fix the ordering of the rotations. A lot of people are more used to roll being applied first, and then pitch, and then yaw. In this case, it looks like they apply roll last. I think they just apply it in order X, Y, Z, because like as long as you're looking straight down the Z-axis, the GLM basic rotation, it looks like it doesn't care what the other orientations are. It just sort of rotates with absolute respect to Z. So this is the rotation that's being applied last. Anyway, getting a little sidetracked. So let's close out of that. Let's decide on a scheme for the scenes. I think it's clear that I do need this to be saved in the entities section alongside the other elements. Let's do Euler rotation hint. That sounds good to me. And then we can do X, Y, and Z. And these will be roll, pitch, and yaw, not respectively, but roll, pitch, and yaw are just rotations about whichever axis. Though I may want to change that a little bit. I don't know. Let me take a look at the inspectors and think about this for a second. Inside of Unity and inside of other engines, a lot of times they'll do the rotation. Let me pick an object. A lot of times they'll do the rotation in the terms of X, Y, and Z. I wonder if I should just label them roll, pitch, and yaw. That might make more sense. How does Unreal Engine do it? I forget off the top of my head. It really doesn't matter which one I pick. Of course, it's Unreal Engine, so it'll probably take 5 years to open, so we'll let that go in the background for a minute. Making the rotation X, Y, and Z based does lend itself well to this clean-looking UI. It also keeps you thinking in terms of the mathematics of it, that you're rotating about whichever axis. But on the other hand, roll, pitch, and yaw tends to imply an order, so that you understand which thing comes first. People in Unity probably don't often think about this, but even though it's X, Y, Z in the inspector, it's actually being applied in the order of Z, X, Y. Roll being the Z-axis. We're not rotating about the absolute Z, we're rotating about the local Z after we have applied the pitch and the yaw. So it might make a little bit more sense for this to be roll, pitch, then yaw. I could even just keep it in the same grid style by having a single letter instead of the full word, so R, P, and Y. But I don't know. How does the inspector in Unreal Engine do it? So we got the rotation, degrees. They don't even label theirs. That's interesting. They do color code it. Okay, and when you mouse over the value, it tells you both X, Y, Z, and roll, pitch, yaw. Oh, that's interesting too. Look at this. Roll, pitch, and yaw don't correspond to the axis exactly. So this is the oh, hang on a second. I think they do something interesting here. I'll have to look this up, but it kind of looks like to me that they've changed which direction is forward in world space to be the X. I mean, forward, backwards, and right and up and down. Those are all kind of arbitrary if you think about it. But in terms of like unit space, like if you're thinking about like before you apply any transformations to your vertices, there technically is an absolute forward and an absolute up and down and right, and you have to decide which way you're going to do it. The way that I've been doing it is that x positive is that way, y positive is that way, and z positive is forward into the screen. But it kind of looks like they're doing x as the forward direction, which means that it's also the roll direction for the rotation. The y is going this way, and then the z is going up. And then they kind of don't have to. They don't have to choose. They can just do. They can just keep the order in the same place. Hey, Goku. That's interesting. I'm gonna Google this. I'm wondering if this is a... I just noticed inside of the inspector in Unreal Engine 5. Have I managed to get Discord? I haven't bothered yet, I'm afraid. I tell you what, I'll look at doing that this afternoon. But yeah, I just noticed that that Unreal Engine has its roll be X, its pitch be Y, and its yaw be Z, which is not actually like that. That doesn't jive with what the forward direction is in a lot of applications. So z-axis points up. Yeah, I think that makes sense. UE4 forward axis is positive X. Yeah, so that's I'm not imagining that. That's interesting. So this kind of neatly solves a UX problem, which is that the ordering of the values inside of the inspector view. Yeah, this is Unreal Engine. I'm referring to it real quick because I just had I've been thinking about how I want to make my inspector look regarding Euler rotation hints, and I had realized that there's probably a UX concern between, if we take a look at Madeline here, this idea of rotation being about an axis, so you have about the x-axis, about the y-axis, about the z-axis, but then also these being applied out of order if you wanted to do roll first, roll being this motion. With Unity, oh, I hear Ancient's going along. Yeah, actually, this part is not very new. By the time you joined, I think I was focusing more on the low-level code and whatever. But yeah, this inspector has been where we've been working on for the last little bit. I just had to do a massive refactor the last couple of streams. That's all done now, so now we're back to fun stuff. But yeah, the ordering here, X, Y, and then Z, I mean, that's throwing me for a loop. So I wonder if this is the entire reason why they chose to make X be the forward direction in world space in Unreal Engine. I thought that was a strange choice. The idea that forward into the screen is X, because like in almost every standard, in almost every graph ever made in mathematics, X is left and right and Y is up and down. And it makes a lot of sense to me to bring that into 3D space and then just have Z be the direction that goes in and out of your screen. But what they did in Unreal is they made the X-axis the forward direction. They made the Y-axis the right direction. And then they made positive Z go up out of the ground. I guess I haven't used Unreal in a very long time, so I forgot about this. And I've never used Unreal professionally, so I this wouldn't have been beaten into my head while I've been working. So yeah, it's like if I made positive X, yeah. So if I look like straight up, like this is the orientation that I treat as forward in relative space. So in the case of Unreal Engine, it's crystal clear that you're applying this rotation first, and then this rotation, and then this rotation. You can even see with the forward vector there how it rotates about as I rotate about these axes. So I think I'm gonna go with the Unity approach now that I've had a chance to digest that new news, because even though this doesn't exactly say roll, pitch, and yaw, I might like do like a mouse over hint that says roll pitch and yaw. I think it's just a lot intuitive for a lot of folks that roll be applied first. So I'll keep it saying X, Y, and Z in the order X, Y, Z, and then just under the hood apply the rotation to Z before X and then Y. But yeah, so back to the level editing scheme. So we'll add Euler rotation hint X, Y, Z, which will be the the pitch, yaw, and then roll. And then we'll do in terms of floating point. So let's say 0, 0, 0. And actually, I think I could just, because this is YAML, we can just do it without the dots, and it'll automatically handle the in-betweens. Cool. Okay, so let's add this Euler rotation hint to each entity, like that. Bam. Okay. And then out of curiosity, if I go to reopen the scene file, close scene file, open scene. It looks like there's a problem loading with that extra information. If I take a look at my debug console, we have a YAML exception thrown, message, end of map, flow not found. What would that be referring to? Let's set a breakpoint on that. So cmanager.cpp, this is where we actually do the loading code. There we go, load C file. And we load the text into a string, and then we pass that to load entities from YAML. And this is a try block around all the YAML CPP stuff, because YAML CPP uses exceptions in a way that I don't really like. And then this is another reason why I don't like exceptions very much, is that I can't like set a breakpoint here and then rewind the stack to see where the problem occurred, because by the time we get to the catch block, we've already unwound the stack. But I can at least set a breakpoint for here, and then we'll reload the scene file. See if we can identify what's wrong. Failure loading. Okay, that's interesting. So before we even get to this for loop, we have an issue. So I'll set the breakpoint a little bit earlier and try loading the scene again. Okay. YAML source should contain everything. There we go. I do kind of wish I had Visual Studio's string inspector. They have an inspector that just like opens up a window and just displays the string as a text document if it's a very long string. Yeah, we got the Euler rotation hint. So this is the file loaded correctly. Stepping over. What just happened? It like immediately skipped out. So the exception occurred when we used YAML load. That's weird. Oh, these are comma separated. I'm an idiot. There we go. And then all of the, yeah, okay. Whoopsie. And we can turn that breakpoint off now. Opening up the scene file again. Okay, so everything still loads because we added data that we're just not handling. Cool. So back inside of the load function, we got load scene file. We'll also need we'll need to start parsing out some information unique to the editor. So I think the way that I'm going to do this is via conditional compilation. So inside of the load entities from YAML, where we pass in just the string information, we will conditionally load the hint. And then the hint information we'll need to store in a location where we can grab it. So, yeah, internally inside of Scene Manager, we use a map to associate the to associate the entity ID with an element inside of the entity pool. That would be this guy here, and then we use that to excuse me, to find the position, rotation, and scale. I think this works good, having an entity pool for this data while you're inside of a game scenario. For the other data, though, having to dereference multiple things doesn't seem great to me when it comes to the editor. So I could do in a completely separate structure from the actual game entity stuff. I could do like a map between the entity IDs and the rotation hints. Yeah, but I don't like that too much either. All right, so what I'll do then, I'll add an ifdef. We'll do ifdef EP build dynamic. And then inside of here, we will add the GLM vec3, and this will be the Euler rotation hint. And then in the game, or in the editor layer, we can access this data. For that to be the case, though, I'm going to need to expose these through the new system of protected headers. So we're going to go to cmanager.h. This is the protected header that we can pass around inside the engine layer and to the launcher and editor layers without touching the game layer. And inside of here we can add, or to be more correct, we can move the entity pool and the entity indices. These guys. So let's do that here. So we've got the entity struct is now going to be defined inside of the scene manager internal header. The entity pool is now going to be an extern. Both of these are going to be EP API, so that they're exportable to DLL builds. And then we'll need the entity indices as well. So that should be these. I think you do export on the structs as well. It might be this way though. I have to do struct, then EP API, and then yeah. All right, cool. And then extern DLL export import requires external linkage, but it is externally linked. We are missing the entity ID though, so oh, that's annoying. All right, I'm gonna have to do I'm gonna have to cheat a little bit. Because entity ID is something that's declared in the public header, I don't actually have access to it in the private header. So in the private header, I'm going to be using UN64T, which is the actual alias for entity ID. And then inside the CPP file, we should be fine passing in entity ID instead, because they're the same type. There we go. So far, so gravy. We don't need to declare the entity struct inside of the CPP file anymore. That's inside the header. Vector, entity pool. Yeah, so we got the entity pool, entity indices, and that's it. Okay. And now this stuff should be visible to the editor. So inside of the loading code, we can now add stuff to the entity layer, and then that stuff will be visible to the engine, because the engine can dereference both the entity indices and the entity pool. So that should work. First, let's make sure that it actually compiles, and then we'll go on to doing the loading code. Now that I've broken up now that I've got the systems into their own namespaces, I might want to consider breaking up the API on CManager, because there's a couple of categories of functions, and CManager.cpp is pretty long at this point. But I'll worry about that later. Okay, we got a redefinition of entity pool. That's interesting. If we go to the internal header, here's entity pool. Oh, because I've got, yeah, like that. Putting it in parentheses is the size. I was statically sizing it, both in the header and in the definition. Okay, excellent. So now we have the ability to add any arbitrary data we want to the entities, and have that be visible inside of the editor layer in a protected fashion, so that these details are still not visible to the game layer. Perfect. So let's head to the loader again. Load entities from YAML down here. And we are going to be looking inside of the entities block. Okay. And then this is where we check for the name, position, rotation, and scale. We actually have it be, we issue a warning if we don't have one of these values. At this point, we are iterating through all of the nodes in the entities block. So entity data iterator is pointing towards the iterator that's pointing towards the entity ID. The second is going to be its data value, and then we are using the accessor position, rotation, and scale on it. So we would actually access the new data using something similar to that. Okay, so inside of this block, we've confirmed that we've got the name, rotation, position, and scale values. And then so far, this is where we've been parsing out the position, rotation, and scale values. However, I will have it optionally load a hint. So we'll say if entity data iterator second, and then we'll say Euler rotation hint. So first we'll say if that exists, then we will populate the hint. So we'll say if it exists, and then if it's a map, else will show warning. If it's a map, then we need to also check. Let me just leave this document open. There we go. So if we have Euler rotation hint, if the type of that node is a map, and then if it has X, Y, and Z. And so in this block, we have identified that we have an Euler rotation hint, that it has an X, Y, and Z, and now we can actually do something with it. So what we actually do is we'll set the value of the entity that we're putting inside of the pool. And the way that we were doing that inside of the other data is that we were first constructing the out position, out rotation, and out scale, and then assigning those to those values inside of the entity pool. So what I'll do here is I'll make a GLM vector containing the Euler hint. It'll have to be outside of both of these if blocks. It'll also have to be conditionally compiled, like so. This will be out Euler rotation hint, like that. And then we'll assign the values here, which I think we call .as float to get those. But because of the way that the YAML CPP library works, I do have to wrap it in a try-catch block. So let's do that. Okay, and there were two different bad type conversions. It looks like there's bad type conversion with entity ID and a float. Oh, because those are the two different types of data that we were parsing. In this case, we're only parsing out a float. So in my catch block up here, I will do float by reference. Okay, and we don't actually need the exception object in this case. I'm actually not clear why I even bothered to put exception inside of this block, because we don't use it. But yeah, and then up here, we'll actually do the conversion. So this is where we would do out Euler rotation hint equals entity data it. We'll say dot x equals entity data it. Second, and I'll just copy this whole block. Okay. Dot as float. Ta-da, like that. And then we'll do this for x, y, and z. Like that. So at this point, we've got the Euler hint out of the YAML file. I'll need a way to inform the position rotation scale code down here of the situation that we don't have a Euler hint in the file. So in those cases, what I'll do is I'll make this an optional. Like that. And actually this whole block should be conditionally compiled as well. So I'll move the if-def around it. Okay. So far so gravy. We do need to do assign it a value. On std optional, do I have to just do, can I just do that? X? Will that work? Like if I don't have a value inside of the optional, I thought this would be like this is a const expression. Let me pick this up. Okay, so I've actually got to use an assignment operator to replace the null opt. And it can take an optional reference as well. So what we can do here is we can say out Euler rotation hint equals std make optional of type glm vec3, and then we can pass in the arguments for the constructor. So in this case, we'd be passing in the Euler hints. It should be this guy. Oops. This guy. This guy and this guy. These guys being the X, Y, and Z that we've parsed. Okay. Right? Yeah. Perfect. So it's a little awkward to read with the claim formatting, but it's not so bad. Now, if parsing out one of these floats throws an exception, the constructor won't complete, I don't think. So by the time we make it out to one of these catch blocks, out Euler rotation hint will still equal std null opt. So I think that we're good here. So let's add some warnings. EP warn, and we'll say load entities from YAML. Like that, and we'll say Euler rotation hint values could not be parsed as floats. Okay. And oops, I'll copy that first line for the other warnings. Down here, oh, this stuff belongs in the if block. Oops. Here. Then down here, the issue will be scene manager load entities from YAML. If it's missing one of the parameters. So we'll say Euler and I probably should be passing in additional data as well. The trouble is that I haven't actually parsed out the ID at this point. But that's okay. I'm gonna leave it like this. Euler rotation hint is missing an axis. Because this data is going to be set by the editor, it's unlikely that a developer will run into a problem like this. And because it's YAML, we can probably just Control F and find which one is missing its axis pretty easily. So I'm not going to worry about passing an ID out of here for me to identify which ID has the problem. Okay. And then this warning was if Euler rotation hint is not a map. Euler rotation hint node is not a map. Yeah. And just keep the language consistent. Euler rotation hint values cannot be parsed as floats. Could not all be parsed as floats. Good. That's a good series of warnings. So at this point, we have Euler rotation hint parsed out. With warnings in case that there's not anything there. And then down here in this section where we normally assign data to the entity pool, we can now assign out the Euler rotation hint. So we get entity, indices, old ID to new ID. This is what all of this means is outside of the scope of what we're dealing with today, so I'm just gonna kind of gloss over it. We'll set its Euler rotation hint to be equal to, I think I can use or value or. This is the first time I've ever used value or for something. There it goes. Yeah, so you you get the optional, you type in value or, and then it'll either give you the value or the thing in quotes, depending on whether it's optional. So in this case, what we'll do is we'll do equals out dot value value or, and then if the Euler rotation hint was parsed from the YAML file, that's what we'll put into the entity pool. But if it's not, because it wasn't added to the file or it failed to parse for some reason, what we'll do instead is we'll derive it from the rotation quaternion from outrote. So we'll say here glm vec3, and can we just pass in a quaternion? Kind of doesn't look like it. So Euler angles maybe. Returns Euler angles, and we can pass in a quaternion there. Right? Yeah. Okay. And then this whole thing is conditional as well. So we'll say if def ep build dynamic, like that. Now we'll have to come back to this because Euler angles doesn't do the Euler angles in the right order. I want those to be roll, pitch, then yaw, but for now this will do. Perfect, save. Make sure that that compiles and runs. There we go. Compiles. Go to run it. Open scene. Got the scene. If I look at the debug console, I don't have any errors. So at this point, we should be able to get the Euler rotation hint out of the entities and use them. So let's confirm that they're actually loaded correctly. Let's close out of this guy. And inside of the scene editor, this guy, we have the ability now to access the scene manager directly. So in this case, I've got Enterprise Scene Manager in the header for what? For getting the max entities constant. Eventually this will be a project property, so we'll have to skip that at some point. But if I go to sceneeditor.cpp, where we do the actual loading, oh no, I'm sorry, this is not in here at all. I don't need access to that. I need access to the inspector, is what I'm looking for. Okay, so in the inspector, we've got the inspector view that we kind of hacked together. There's a couple of big changes that we need to make here, but we'll come back to that. So for starters, here where we get the rotation, we get it. We have been getting it so far by using the public API's get entity rotation, then converting it to Euler angles, then into degrees, and then passing it to rote. Now we have a different way of going about it. Entities I is the index, or the entity ID, and we can use that inside of some of the private members. So heading up to the top, I'm going to add the internal header now. So go include EP internal scene manager.h. And now I should have access to the stuff that's declared in the private header. In particular, we're looking for this guy, Euler rotation hint, inside of the entity pool. And for that, we need to get access to entity indices. So the way that this is going to work is it's going to be we wrap entities with entity indices. So we pass in the ID into entity indices to get the index into the pool that ID represents. And then we access entity pool at that index. And this gives us the entity structure representing the data. If I go to hit dot, oh, it's not giving me. Oh, I have to scope these. EP, scene manager, entity pool, and then the indices. And now if I go dot, I get the data from the private data from the entity structure. So now I've got the ability to access the Euler rotation hint. Yeah, I think that's pretty much it. In order to make this a little bit easier to read, I'm going to use the using directive on entity pool and entity indices. And this is another reason why the namespaces are better than what we had been doing before with systems. Because if, in the case of types that are located inside of classes, you can't actually scope using the using keyword to the type. You have to scope to the topmost type, which is the class. So now we can scope all the way in with our aliases. or with our using directives. And then I needed entity pool, I needed entity indices. Cool. And then this can go like that. Cool. Vec3 rotation, entity pool, entity indices, entities, dot Euler rotation hint. So now we've got the Euler rotation hint showing up inside of the inspector. So this is when we're populating the inspector view. And then down here, if we have at least one entity inspected, or one entity selected, we then add the transform component. Using rote floats. Oh, you know what? We're not quite done here. I've got the Euler rotation hint. No, that's in degrees. That's right. So I've got the Euler rotation hint in degrees. We're going to store it into the file as degrees. And then the rote floats, which have to be an array of floats for the sake of the IMGUI API. We check to see if they're not equal to not a number, or if yeah, we go through all of the entities and we check to see whether they differ in any way, and we assign not a number if they do differ in some way. Okay, and then down here we actually will set the value if we changed it. So if rote floats is equal to a number and not equal to not a number, which is what this gibberish means, then we will set to either the value we parsed out, or we will convert from Oh, okay, hang on. Yeah, we're using set entity rotation here. So when we use set entity rotation, we pass in a GLM vec3, and then that converts. We use that in the constructor of the quaternion. Yeah, and the GLM function accepts radians. So we're going to need to convert So I think we're actually not going to use this code at all. Instead, we're going to go into Scene Manager, or using the aliases from above, we go into entity pool, entity indices, and so on. And we set its Euler rotation hint. To be equal to rote.x, rote.y. Actually, I can just pass in rote. And then we'll conditionalize this upon if we've made a change. This is gonna be a little harder than I thought. So I'll keep this code, but I will get rid of the set entity rotation stuff. Instead, what we care about is if rote floats is a value, meaning that we've set it, we've displayed it and set it from the editor. Then we'll set entity pool, entity indices, entities I dot, right? What's wrong with this picture? Yeah, I'm not really sure what this is complaining about. Entity pool is a vector of entities. We're indexing in using size t, which is the right type. Oh, the IntelliSense has gone away now. Well, the error went away, but... Okay, it was just IntelliSense being really slow. God damn it. Entity pool, Euler rotation hint. My brain's thinking in circles at the moment. I'm going to take a little bit of a break, get some water, and we'll come back to this in like 5-10 minutes. All right. Cool. I'm back. So where did we leave off? We got the Euler rotation hints being parsed out of the file correctly. We currently don't have them being saved to the file because we're not doing scene file saving quite yet. At least not from the editor. And we were trying to sort out. Let me comment out this code, bring this code back in. We were trying to sort out the appropriate time to make the translation to and from the Euler equals. So we've got the transform component. Each frame we will get the rotation value from the Euler hint that's stored inside of the entity in dynamic builds. So we'll get the Euler hint, so that'll come in as degrees. Excuse me. From there, we display them at unchanged in the inspector. The inspector will either display the value itself if all of the selected entities agree on a particular value, and that's where we were using not a number as a stand-in for hyphens or something that will make it look a little bit nicer later. Then that'd be down here. If we have at least one entity selected, we display the drag float. The drag float will write out the value if, whether or not it's been changed to rote floats. And then at the end, we go through rote floats, and if rote floats is a valid number, then we need to set the entity rotation for every selected entity back correctly. Yeah, so what we'll do then, we'll need to set all of these values back at once. That's a little bit different than what we got here. So we'll need to do an if rote floats 0 equals rote float 0, and then we'll duplicate this a few times. And change these values. Like that. So what we're saying here is if rote floats equals 0, or rote floats 0 equals 0, rote floats 1 equals 1, and so on. So we're just checking to see that they are equal to themselves. This is a way for us to confirm that they are a number and not flagged as not a number. So in short, if the values are all valid, then we will write them out. Oh, that's not going to work. Because what if they agree on a pitch, but not a... How does Unity do that? If I've got two entities selected, and I set an X rotation... Okay, that's interesting. I'm going to start with setting an entity's rotation to be 0, 0, 0, 0. Do the same thing for this guy. 0, 0, 0. select them both, they both show up. If I change one axis on one of these and select the other. Okay, so the way that Unity does it is that if neither of the values match, so if in this case they agree on the y and the z, they don't agree on the x, but because they disagree on one of them, none of them appear. I suppose that makes sense. Because if you're trying to set rotations for these in this fashion, maybe you want to ensure that they actually have matching rotations. On the other hand, yeah, I guess if you wanted to keep their values separate, then you would use a widget, which is probably the way that you do it anyway. Yeah, so we'll do it like this. So if all of the values that we got back are valid, then we will do the set rotation. So that will look like entity pool at entity indices at entities I, which is our iteration through the selected entities, dot Euler rotation hint equals I guess we would say at this point we would construct a new one from row 0, row 1, and row 2. Like that. How are we doing on levels? Yeah. Good. And then else I guess else will just leave the rotation hint, so we don't need to consider else. So at this point we've updated the Euler rotation hint for the entity. We'll need to set the entity rotation back. So we'll say we'll do this in a slightly similar fashion. We'll say rotation equals GLM quat GLM radians and pass in the Euler hint. Okay. So basically we're checking to see if at the end of the frame all of the rotation values are valid from the sliders, because if any of them aren't, then that means we've selected entities that disagree on their rotation or on at least one of their axes on rotation values. And if these are valid values, then we write them back out. We directly set the Euler rotation hint, and then we convert that into the rotation. Okay, and because we are reading the Euler hint into the editor instead of translating it from the quaternion, the translation here only goes the one direction. So we set it in the editor, and then that turns into the quaternion that's used in the engine. Currently there's not a mechanism for for setting that back from inside the game code, translating from the quaternion to the rotation. We'll come back to that. But yeah, we've got a block going here. So this should probably be okay. Let me close and relaunch the editor. I thought it was going, but I guess it wasn't. Okay, there we go. We'll open up the scene file. This guy. We'll select a sprite. We've got the x-axis, the y-axis. Look at that, the y-axis isn't breaking anymore, and the z-axis. So, okay, so that's step one done. We've got rotation hints working inside of the engine layer. The ordering is still wrong, but you can see, like, as I go about, I'm actually able to exceed the bounds of negative 180 to positive 180, and I'm actually okay with that. That is what I'd prefer. Do we have? How does it work if we select multiples? Okay, so a couple weird things happen when I select multiple sprites. Let me select just two. So one of them is set to not a number because they disagree on that axis. If I make them identical and I try to do a setting, then yeah, then they're both wrong. So this seems to be working better for the individual selection. We're going to need to add some better rules for multi-selection. If I was to select two of these at once and then change their X or Y position or whatever, those will work in unison, as long as they agreed on a position in the first place. But in the case of rotation, even if they agree on a translation in the first place, I can't set a rotation on them without it reverting back to not a number. I wonder why that is. I'm not really clear on why that would be. Okay, so we've got at least one entity selected. The rotation is set to the rotation hint for entity I. Oops. You know what? This method of multi-selection is probably making this harder than it has to be. What I was doing before was I was using the entity bit select status bit field, which was a requirement of the hierarchy panel to serve as a list of entities that I need to iterate through. But I probably should just have a separate data structure for which ones are selected. Let's go to sceneeditor.h. I'm going to add next turn we'll do an std. Yeah, I guess we'll do a vector. And this will be a vector of entity IDs. So EP scene manager entity ID. And this will be selected entities, like that. We'll throw this definition into sceneeditor.cpp. Up here. Good. And then selected entities will be inside of the hierarchy.cpp. Where we go to handle multi-selection. We needed the entity select status bit field because we needed to pass in a we needed to have IMGUI know the state, the selected state of every single entity. So it wound up being that we were iterating through the entire entity list anyway. So I just made a bit field where each bit represents the entities. In the case of knowing which ones are selected, though, at the beginning of this draw call, I'm going to say selected entities not clear. Oh, except for I need to do scene editor. Selected entities not clear. And then this will be empty. And then we can start inserting any that we need to set. So we'll say okay, so we're going through all of the entities in the scene. Select IMGUI selectable. It adds the selectable object. And we are passing in a bool to indicate whether it's already selected. And that's this. Entity select status BF, whatever. And then after that, we draw a box around the shift select anchor to make it easy for multi-selection to work. Then we go through all this logic here. If is selected, which is the return value of selectable. And then we if we're doing single selection, we'll clear the selected status of all the other entities. So where we do the mem set on the bit field, we'll also say selected entities dot clear. Scene editor selected entities dot clear. And then we will, where we go to add the, set the bit for the single selected entity, we will say dot in place back. Actually, we don't need to construct anything, so dot push back, and push in the entity at I. So we got entities I, like that. Okay, and then if we're doing a shift select, we go through all of the IDs between the shift select anchor and the other, and we set those bits. So what I'll do is I'll say, oh, that's, oops. Yeah, the annoying part here is that I don't know whether or not the entity is already listed as selected. So maybe a vector wouldn't be a good choice here. Maybe instead of a vector, we did an std set. Cool. And then we do dot insert on the entity ID. And we'll do the same thing here for everything that we're shift selecting. And the advantage of the std set is that it won't insert the same key twice. So we'll have a, yeah, we'll have a decent selection there. Cool. Okay, and this is the case where we don't already have a shift select anchor, so we're doing a single selection. Or we're appending to the list of selected entities. So we'll do the insertion again for entities I, like that. And then we add the shift select anchor on top of appending the entity ID to the selected entities. And then control down is where we do where we continue to append individual items without selecting a range. So that's down here. Find shift select fingers. So first we're checking to see whether the thing that we clicked on is in the shift select anchors, and if it is, we remove it from the shift select anchor list, and then we remove that item. So in this case, we would say selected entities dot erase, and then pass in the key that we want to erase. So that's going to be entities at I again, like that. And then down here, this is if we don't already have it selected, we add it to the shift select anchors list, and then we mark it as selected. Like that. Okay, so now I should have a std set selected entities. That's going to be much easier to traverse list of things that we have selected in the scene, the list of all the entities selected. It'll clear whenever we clear the bit field, so it's as good as the bit field, except for we don't have to iterate through every entity in the scene in any other panel besides the hierarchy, which actually has to iterate through every entity in the scene. All right, so far so good. Cool. And back to where we were in the inspector then. we can change up a lot of this to simplify it. So pos floats, rote floats, and scale floats, these are going to be the floats that we pass into the IM GUI. We do need those. I can get rid of at least one entity selected because instead of using it, we can just access the size of the STD set. I also don't need to get all of the entities in the scene anymore. I can just go through every entity and the selected entities. So it'll be EP, scene manager, entity ID. For every entity ID entity in that set. And these are just integers, but I'll do it by reference. Can I do it by reference? Qualifiers, dropped, binding. Yeah, that's fine. So we got, we're going through the entities that we have selected directly instead of going through the entire bit field and finding the ones. Okay. And then the logic that we had from being not a number. I think we're going to need to scrap that now as well, because it's making it a little too complicated to handle when the entire inspector line should be blocked out versus just a single value. So instead of doing this whole not a number thing, we're going to need to track whether the selected objects differ in some way. So we'll do the position and scale first, because those are the more straightforward of them to work through. Modeling after Unity again. If you've got multiple entities selected, are these scales different? Oh, I guess they are slightly different scales. If they agree on a scale and you can set the scales identically. If they disagree on a scale and you go to set, it'll only set the one selected. Same thing with the X, Y, and Z axes. Rotation being the one that does all three. So I guess we can do GLM. Well, I don't need to store pos, rote, or scale anymore because I don't need to use the getters. I can just access entity pool, entity indices, entity dot whatever. So we'll do dot position. Dot x. I'll assign the I'll assign the values for using the inspector. I'll do the same thing for scale. I'll do the same thing for rotation. Actually, this will be Euler rotation hint. Okay. I'll need a way to track whether the transform component should be blanked out or not. So for each one of these, I'm going to associate a Boolean. I'll say is whatever aligned, whatever being pause, rot, and scale. And default those to true. So if while we're iterating through these, we come across something that differs, then we will mark this as false, and then that'll change how we draw the inspector element. In the case of position and scale, we actually care about alignment on multiple axes, because we want to be able to independently align X, Y, and Z on scale and rotation. So I'm going to add 3 of these. Is pause X, pause Y, pause Z, and then we'll do is scale X, scale Y, and scale Z for each of those. And then is rot aligned, we will just have a single Boolean for the entire rotation. Okay, good. Now, how do we determine when alignment breaks? We somehow need to be able to compare the new entry against the old entry. So I'll actually break out of this whole nested entity situation. What we'll do instead is we'll do if scene editor selected entities dot size, meaning that it actually, where do we have an empty? So if it's not empty, so it's got at least one element, we will do all of this for the first entity in selected entities. So scene editor selected entities dot front or find first begin. I guess we'll use begin and so on and so forth. And we'll set the initial value of these to be equal to whatever the first element is. And then instead of doing a range-based for loop like this, we'll actually go ahead and do iterators. So we'll do for auto entity it equals dot begin plus 1. And then we'll continue on from there. That should be, or plus plus. I think it's plus plus dot begin. So what this will do is it'll initialize the iterator to be the first after begin. And then we'll say entity it not equal to seen under selected entities dot end and plus plus entity it. Okay, so now we've got a for loop where we're iterating through entities 2 through n, and then we can dereference entity it for these guys right here. Cool. And then inside of this, where we're going through entities 2 through n, this is where we'll actually implement the check for alignment. So we've got pos x, pos y, and pos z to check. So we'll say if pos floats equals entity pool position.x, then we're good. If they don't equal, though, then we'll need to set alignment to false. So we'll say, we'll check not equal. And if they're not equal, then we'll say is pos x aligned equals false, like that. And we'll do something similar for the rest of these. But these will be pos y, pos z, and these will be, well, those will be x, y, and z, but it'll be scale, not pos. All right. And then for rotation, we actually only need to check, well, we need to check all of these. But we're going to do it in a single if statement. So it'll be if rotation floats 0 is not equal to what's in the entity pool for this new entity. For any of them, if any of them don't align, then the whole thing doesn't align. Like that. Okay. And there's no need to reset the values here, because if they're not aligned, then we if they're not aligned in the first place, then we don't bother using these values. Okay, cool. Good. So this is a more correct way of identifying whether selected items have an aligned axis on scale, rotation, or whatever. And it's also not iterating through the entire scene, which is good as well. Okay, so the next thing to do is to actually display the drags. So I'm going to close all of this out. That's invalid code now. And instead of doing at least one entity selected, we will do this. Oh, but you know what? We can actually wrap this whole thing in that. So we don't actually need to execute any of the rest of this code if we don't have anything selected. So I've wrapped the whole thing with the check selected entities.empty. Okay, good. And then down here, we know that there's at least one entity selected, so that check is not valid anymore. InGUI collapsing editor transform will make the block no matter what, because we got at least one entity selected. And then we want to add the correct floats. So yeah, I think I'll stick with. No, I can't stick with drag float 3. Drag float 3 was basically a way to automatically set up 3 scalars. But I need to be able to display things in the scalars that are not values. So I need to actually conditionally check each of those booleans that we set up and display either a scalar entry box or display a text box with dashes that's not interactable. However, I'm gonna make this I'm gonna mark it as a to-do for the second, and then I will do like a specific code word number to indicate when the items are not aligned, so that I can at least check that the logic's working before I bother getting into the UX stuff or the UI stuff. To do display either a float slider or dashes, depending on alignment rules. But yeah. And yeah, I'm just gonna hack together the same thing that we did before, where whenever we have an alignment problem, we will set the value to be not a number. Like that. Not a great way of doing this, but good enough for the moment. Now we aren't also using not a number to indicate we're not also using it as a bool. We actually have dedicated bools now. So the only purpose of doing this, not a number, is to display whether there's an alignment problem. There we go. And last one. Okay. And then down here, when we go to display, it'll display not a number if there's an alignment problem. And in the case of rotation, this will now newly display not a number for the entire row if there's an alignment problem on a single axis. Cool. And then we don't have to do the iteration through the entire thing anymore. We just need to iterate through the selected entities. In this case, we can use a range-based for loop because we don't need to treat the first element different from the second through nth elements. So this will be scene edit or scene manager entity ID. What's going on here? Oh. Entity in scene editor selected entities. So for every entity that we've got selected, we will update the values if they had changed. So we'll say if is aligned or is pos x aligned, then we will set the pos x. We don't need to use the getter anymore because we have private access to this stuff thanks to the refactor. And we can do entity pool, entity indices, entity. And this will gain us direct access to the structure in the engine layer. We can say Euler rotation hint is now equal to, or dot, sorry, Euler rotation hint dot, we're on position. So position dot x equals the value that we got back from IMGUI. So in this case, it's pos floats, pos floats at 0. And then we just rinse and repeat for the remaining vertices, or the remaining floats. So we got if pos y is aligned, then we assign y. We'll have to do the same thing for scale. And rotation. Hang on a minute. So actually I need even more. I need 9 of these. And so these will be, instead of pos x, it'll be is scale x aligned, and then we'll do scale, the scale element for these. Hey Jolo, welcome. We're doing all right. I'm going a little slow, to be honest, but it's nice to be back working on this. How are you doing? How's your night going? Then down here we need to deal with rotation. Except for this is one Boolean, so we just do a single block check. Just playing some Valorant. I've got a couple of friends that play Valorant. I've just never bothered to pick it up. I know it's free, I just haven't done it yet. I remember you and I were talking about this before. You were giving me some good reasons to take a look at it. I had thought it was just an Overwatch clone, and you were pushing back against that. I think it's is-row aligned is the name of the variable. Is-row aligned, yeah. Cool. And then we are setting the Euler rotation hint now. Dot, x, y, and z. to be, oops, to be, rot floats. Okay. And we can get rid of this whole block. Okay, so we've now got a better method of iterating through all of the selected indices or selected entities, setting their position, rotation, and scale. The one thing left is we need to do conversion from the Euler hint to the quaternion rotation. So we'll have to do a little bit of work here. So for the regular rotation inside of the entity struct, we will set that equal to glm quat, and we'll pass in the Euler hint, which is already in glm vec3 form. We just gotta look it up from the entity pool. Okay. Okay, that's looking good to me. Yeah, let's try that out. Compile just fine. Open scene. Got the scene. Grab a sprite. Okay, that was interesting. I went to select a sprite and it automatically reverted my selection. So I must have screwed up my selection code from before. That would be in the hierarchy view, where we added the selected entities. Oh, hang on. Yeah, I don't actually want to clear the selected entities at the start of this. Do I? Hang on. No, I don't. Okay, so if we do a select an empty space, we have to do the clear down here. We add all the selectables. We draw a box around the most recent shift select anchor, or the active shift select anchor. And then if the selectable returns selected, then we handle multi-selection. Single clicking will deselect everything and then select just the one. Holding down shift will select everything in the range between the shift anchor and the new selection point. If there's no shift select anchor, then we simply append the item as if it was control clicked, and then in control clicking we append and append. Yeah, that's looking good. Or append and deselect on an individual basis. Okay, that's probably right. Let's rebuild that. Run it. Open up the scene. Okay, and then selecting. Okay, we still got a problem. I'm curious to know how the rotation works, though, if it works any better. Okay, it seems to be working, but I don't think I've translated from radians to degrees, so let's look at that. And then we'll figure out what's going on with the selection position changes. Okay, so for starters, we get the Euler rotation hint from the scene, using that new hidden variable we added to the engine layer. That's going to be coming back in degrees. We check to see whether the value of each additional selection beyond the first agrees with the other. If they do agree, if they're equal, then we proceed as normal. Otherwise, we mark is road aligned false and set it to not a number. All of this is dealing with Euler. Haven't gotten into translating quite yet. Actually, we only translate at one place, and that's down here. Valent really just is a modern sci-fi-ish. Technically, it's a sci-fi game, but it doesn't feel like one. CSGO. Yeah. Yeah, there's a lot of quote-unquote modern day boots-on-the-ground experiences now. They'll do plenty of sci-fi elements. Just because of Hollywood, people think that we have all kinds of secret sci-fi tech in the armed forces and things like that. I take it, though, that it takes place in a different world. Don't people have superpowers in Valorant, or is that all just sci-fi tech? Yeah, so this is where I failed to do the conversion to rotation, or to degrees. So we've got the Euler rotation in degrees. We need to convert that into radians and then pass that to GLM quad. So GLM radians and like so. Right? Oh, yeah. It autocomplete substituted radians for entity pool. All right, let's try that out. Okay, the X is looking good, and you'll notice that the rotation is going beyond that clamped range now. And we don't have that bug with the Y either. And yeah, okay, this is looking pretty slick. So they're still being converted in the wrong order, or being applied in the wrong order. We haven't addressed that yet. Right now we're just getting everything working using the GLM quat constructor. But we will need to replace GLM quat with something that actually does the roll first, and then the pitch, and then the yaw. But yeah, the immediate problem of flickering while we try and adjust this angle, that's completely gone now, and we are no longer clamped in the negative 180 to positive 180 range on any of these axes. Now, let's figure out what's going on with the position, because I wasn't expecting that to be a problem. But apparently it is. For some reason, the positions are being hard set back to 0. Well, the x and the y are being hard set back to 0. The y is being unaffected. The z and the, okay, I probably have a typo somewhere. So that would be right around here, probably. It's x-aligned, is y-aligned, is x-aligned. Yeah, this needs to be xyz, not xyx. XYZ 0, 1, 2, XY Z, XY Z. Okay, hopefully that's all there was to it. Opening up the scene file. Okay, so we're not having any of that jumping going on anymore. The inspector seems to be showing the positions correctly. I can do the modifications. I can select these and do the multi-edit. Because of the way that I'm displaying the not a number on these boxes instead of dashes, I'm not able to click and drag from here, but I could do... oh, I can't. That's interesting. I thought I could type in a number, but... Oh, but I can't because I've already marked them as not aligned. Okay. I would have to unmark them as aligned, or as unaligned. I'd have to remark them as aligned in this code here in order for me to be able to edit the X and Y and put them back into alignment. But yeah, if we take a look at the rotation though, this is going to be something new. By default, the selected entities, let me reset the scene. By default, they all share the same rotation and whatever. But now, if I make one axis differ on one of them, and I do a multiple selection, instead of just dimming out the one axis that differs, it dims out the whole row. And that's because of the new way in which we are dealing with alignment. Let me reset the scene again. I habitually use Control Z to try and undo, but I haven't added undo yet, so it's not going to work. However, something interesting is happening here. I've selected sprites 1, 2, and 3. That's this entire row, and I can, when I go to change the rotation, it sets on just sprites 1 and 3. And it also seems to flicker, like they're no longer aligned, if you notice that, at a certain point, probably around the 90 degrees mark. At a certain point, they started disagreeing on their rotations. Yeah, so there's still some wonky multi-select problems with rotation. Oh, hang on. Look at that. So first, I think this is a problem with multi-selection. I think that it's when I do the shift click on 1, 2, and 3, I think we are not adding sprite 2 to the list. Sci-fi is a place and it takes place in a different multiverse with a special element. Exists, gives people abilities based on their strongest feelings, but for some reason another universe wants to extract those. That's pretty cool. Yeah, that's pretty sci-fi. Yeah, so we got some progress here. We've also got some problems. So there's an issue with the multi-select, and there's an issue with the rotations a little bit when you're using multi-select. I'm going to take a little bit of a break. I'm going to be back in probably like 5 to 10 minutes. And then we'll get back to work on correcting these little weird issues with the rotation. Alrighty. I'm gonna go ahead and turn off the music for the rest of the stream. I think it'll just make it a little bit easier for me to focus. But where do we leave off? So we got the fundamental problem of rotation pretty much solved, actually. We can now load Euler rotation hints from the scene file. I suppose that's an aspect we haven't quite tested yet, because we aren't at the point where we're going to be setting. We're not quite at the point where we'll be setting or saving the scenes out from the editor. We'll get there. We are technically most of the way there, because I have a serialization scheme figured out for systems like the excuse me, like the renderer 2D, where we have an abstract layer that allows you to save out data. But let's quickly confirm that we can actually load a Euler rotation hint from file. It actually doesn't matter if I save the correct rotation in here at the moment, because right now we're just reading the Euler rotation hint, putting that in the editor, and then writing that back to the quaternion after the fact. So we'll do on sprite 1, we'll say 45, 15, 35, and 45, and these will be degrees about the x, y, and z axes. And just confirm that they actually load up that way. Open scene. 2, 3, 1, 2, 3, 1. We are missing sprite 1. Debug console. Cannot deserialize entity 1, 2, 3, 4, 5, 6. Invalid transform values. Huh. Why would that be? Oh, I accidentally deleted the scale. That's why. Okay. Okay, and there it goes. When I selected it, that was when we were doing the inspector code. That was when it translated back from 1535/45 to the quaternion. So it does load into the hidden engine layer, the Euler hint, separate from the quaternion. So that's all I wanted to test. Cool. We're off to the races. All right, now we need to worry about the multi-select thing. Specifically, when we go to Shift Select 1, 2, and 3, and we go to edit one of the values, doesn't matter which value we're setting, it is not treating the middle value as selected. So let's head back to the hierarchy, the hierarchy code, and review our Shift Select stuff. So we have Shift Select anchors. We go through. So we iterate through every element between the Shift Selected entity and the Shift Select anchor. We take and we mark, we set the bit associated with that entity, with every entity inside of that loop. And then we insert the entity at I. That seems really straightforward to me. But for some reason, we are getting the first and the last, but not the one in between. So maybe there's a problem with how I'm getting the entity ID. So we're getting every entity in the scene. We have to iterate through all of them to display them in the hierarchy. We're looping through literally every one, and they are in whatever order they return as. And we continue to use that order throughout the rest. So if we do entities I, that should be correct. I think I might be missing something here. So we get the entire list of entities in the scene. They could be in any order. And the order can change between frames if there's an entity added or removed. The ordering might not even be the same for the existing entities. We cache the size of the total entity count. Why do we cache the size? I think we cached it before because I was using it in the old hacky method. Yeah. Before I had actually decided to do an STD set for the selected entities. Yeah, so this actually doesn't even have to be an extern anymore. This can be in the hierarchy up here. As a static. Yeah. Let me make sure that compiles all right. I screwed up something. Oh, the program's still running. Huh. There we go. Builds just fine. Good. And then back to the scene editor. Or not the scene editor. Back to the hierarchy. Got shift select anchors. I guess I'll just search for any use of the bit field, make sure that each one has an associated modification to selected entities. I think I have to get rid of the bit field. This is a problem I didn't anticipate when I was first writing this code, but originally I had decided to use a bit field because I needed to pass in a Boolean for every single entity that we would show inside of the hierarchy. Basically, for every entity that's actually in the scene, I needed to pass in a true or false to IMGUI to tell it whether it's selected. And so it in some sense, IMGUI makes the assumption that I'm going to store the result as a Boolean. And so what I did is I just followed suit with that paradigm, but I used a bit field instead of an array or a vector of Booleans. However, the problem here is that we aren't iterating through all the possible entity IDs because those are quasi-random for the most part. we are iterating through the index into the current list of entity IDs, and that can change from frame to frame. So it's possible for my selection to become invalidated completely just by creating an entity, and I don't want to add special handler code for that sort of a situation. So I'm actually going to just completely get rid of this, and I'll just use the selected entities set for everything, because at the very least I can guarantee that we are only dealing with the that we have a single source of truth regarding the which entities are selected, but also that the selection does not get invalidated whenever I create or delete or reorder my entity pool. So let's switch to using it for everything. So for starters, it doesn't have anything in it to begin with. We have scene editor selected entities clear, where we would have done the mem set to 0. When we go to do selectable, instead of doing the bitwise math to check to see whether that entity's bit has been set, we will do scene editor selected entities dot count at the key, which is going to be entities at I. Cool. And while I'm here, this can actually be simplified a little bit, because we can do, instead of get entity name, we can do entity pool, entity pool at entities at I, or entity pool at entity indices. Oh, did I not? Oh, I was thinking I was in the other file. I'll just leave it to be get entity name for now. In the other file, we had actually used the using keyword to bring in the pool and so we can directly access these elements, but we don't need to do that for a hierarchy. Okay, scene editor selected entities dot count. So if it's among the selected entities, then we will mark it as mark the selectable as selected. Okay. Down here, where we were mem setting the selected entities back to 0, we'll call selected entities clear instead. And then here we were doing an or assign. We were setting the bit for the entity ID at I. All right, so that's looking good. Now this is the inner loop for the range-based selection that doesn't seem to be working quite yet. However, the logic seems to... Oh, the logic is broken here because I'm using I instead of J. That's why. Okay. Line 82 JRI. Yeah, you saw it just you saw it just before I did. That was a typo. So that's probably why shift select's not working. But I still have to get rid of the bit field situation because of the same problem I mentioned before. So I'm going to continue what I'm doing. And plus it'll simplify the code quite a bit. Yeah, and then in here, instead of using the bit field to check, we will use the scene editor selected entities dot count at entities at I believe. Right? Double checking my code. Yeah, that's right. So if that entity is already selected, then we will remove it from the shift anchors if necessary. Shift select anchors might be a problem. I'll come back to that in a minute. And then we erase entities at I. Yeah, and then here we do the insertion of entities at I. Okay. Shift select anchors. Let me take a look at that. It was originally a list of Uint64Ts. Let me search for how I've been using it. So I've been using indices into. So that's been a list of indices into the entities list instead of entity IDs. So I'm going to change this to be a EPC manager entity ID. So we're actually going to track the entity IDs directly of each shift select anchor. So I'll go back through that list. If shift select anchor is .size, meaning it's not empty. Actually, can I do empty? No, empty's not available on lists. If it's got a size, meaning that it's not empty, and the back element is equal to, instead of making it equal to I, we'll check if it's equal to entities at I. If I can spell that correctly, entities at I. And then that rest of that should be fine. Shift select anchors dot clear. Instead of pushing back I, we push back entities at I, like that. Good. Except for now when we go to do the shift select, before I was comparing the indices directly, I need the indices here doesn't actually apply anymore, or at least not in the same way. Ugh. Okay, so we're iterating through every entity in the scene using I. Okay, so shift select anchors actually does have to be index-based. Because its entire purpose is to figure out the range in the order of the entities that are in the hierarchy. The whole point, in other words, is to iterate through the entities array, or the entities, is that a vector? Yeah. So shift select anchors does actually have to be index based. So does that mean that everything else is correct then? It kind of does. The one potential problem is that when we get to the point that we're going to be inserting or deleting entities, that can screw up our selection because it'll be possibly reordering the list of entities that we have loaded in the hierarchy view. So if we go to create an entity, I guess this would kind of be a moot point because when you go to create a new entity, you'll expect that entity will be selected automatically, which would clear out shift select anchors anyway. But if we go if we select a number and we delete, that's fine. We're okay. If you were to select a number of elements and then delete, or entities and then delete them, then they're already missing and can't be selected afterward anyway. So that makes This all makes sense. Okay. Had to gut check myself for a minute. But yeah, these can all go. All right, let's try that out. Cool. Okay, so shift selecting is working now for the position and stuff and whatever. That is the middle element is being modified. Rotation seems to be working mostly all right, but there's a slight hitch with the yaw. They wind up being at slightly different rotations. Or at least they look like they are. Oh, my brain is doing tricks on me because I'm in a perspective projection. Hang on a second. So let me select sprites 1, 2, and 3. No, I don't think I'm imagining that. Just to make this explicitly clear, I'm going to go to the scene view and change my camera to be orthographic. So on this one, I will comment out the perspective. And instead of doing GLM perspective, I will do GLM ortho. Ortho takes a left, right, and so on. So this will be I guess I'll do continuity width by height. Yeah. Float L or float half width equals this. Those should both be floats. Yeah. And then height will be 1. So we'll do on the ortho we'll do negative half width on the L, half width on the right, and then the bottom and the top are going to be -1 and 1. And I don't need to explicitly specify the floating point type here because I'm not dealing with hot constants. All right. So I've screwed something up. Not really clear what though. I suppose this whole thing should be divided by 2, but that shouldn't matter for what I'm trying to deal with. Ortho takes, yeah, left is -1, right is or negative half of the aspect ratio, positive half of the aspect ratio, then -1 and +1. Oh, that should be -0.05 as well. So that it's 1 in height. None of that should matter. That should just be making it bigger, not. The position and the rotation are calculated the same way as before. The only thing that's changed is my projection. Okay, that's interesting. So I moved forward a ways, and now I can suddenly see link. Yeah, something is off. Let's make this bigger. Let me make this a little bit bigger. Okay, width divided by height times 2.5, and then that'll be half the aspect ratio, and then the height will do. Actually, the height will be 2.5 as well. So this will be a window that's 5 units tall total. And run that. Okay. Moving the camera forward a little bit. Okay. It's acting like there's a clipping plane. Is there? Hang on a minute. Maybe I've misunderstood how ortho works. left, right, bottom, top. Is there an overload with... Oh, there's a z near z far. I don't know why in my head I was thinking that it would do infinite, but that's not a thing. That's not a thing with NDC. You have to always translate the or transform the bounds of a prism space into... Yeah, whoopsie. All right. So on this one, we'll say negative. Let's do negative 100 and positive 100. On the near and far. Okay. Good. And do this again. Okay. All right. So now I've got an orthographic perspective now, which is a little awkward to control. Given that I'm using 3D controls in an orthographic space. But this will allow me to confirm whether these are actually rotating at the correct rate. Okay, so they seem to be identical when I use the x-axis. And just to be extra sure, they do completely match with the rotation about the z-axis as well. But when I go to rotate about the yaw, okay, interesting. They do seem to match. I had thought when I was looking at this, and let me angle down a little bit to make it a little bit more clear, which direction they're rotating. I guess the perspective projection was playing tricks with my brain because these are sprites were in total black space. But what I thought was happening was that when I got to positive and negative 90 degrees, that it would sometimes flip, and then the rotations would be off by 90 degrees from each other. But no, they seem to match. Maybe I have to do multiples at the same time. No, those rotations seem to be working correctly. Well, they seem to be working identically, at least. All right, cool. That's a good test then. So the multi-select on the rotation is working fine. It was just my eyes playing tricks on me. We will now go back to the perspective camera. Orthographics just hard to follow without, grid lines or a background space to juxtapose your perspective from. But yeah. Cool. Yeah, so that's the inspector working correctly, technically speaking. The last elements that we need to add are kind of nice to haves. Yeah, no problem, Jello. So now that we've got this going where we can correctly do, where we can correctly do multi-selection and multi-edit on rotations and stuff like that. We probably should be looking at ways to make this nicer. We have the not a number as a stand-in for a slider box that I wanted to have dashes in. Additionally, I can't click and drag on one of these to override the setting. So to come back to our perennial example, if we have multiple elements selected with differing items, I've got dashes to indicate that these items don't align on these axes or whatever. And then when I go to click and drag on one of the axes that doesn't align, it forcibly aligns it. These have two different x values. Now they have the same x value. So we're going to be looking at GUI stuff for the next little bit. Once I've got a relatively serviceable solution where I can at least do this, where I can at least click and drag to override the selections where they don't align, then I think we'll call it a stream. Because at that point it'll be actually really quite straightforward to be able to position and rotation to set the transforms for all the entities using the inspector. And from there we would be looking at gizmos, so we can do it in the viewport. We'd be looking at mouse picking to be able to select items from the viewport. And then we'd be looking at expanding the inspector to support additional component types. So for example, the sprite components that are attached to all these that tell us what filters to use, what texture to use, what the UVs are, and things like that. We want those to be visible inside of the inspector, and we also want it to be visible in a portable manner and a reflective manner as well, because the whole idea of the framework is that we're going to be making it possible for you to add your own game-specific component types relatively easily, and then expose any little thing you need to the editor. That's probably going to be a big ask. I'm going to take my last break. My throat's just perennially dry. I'll rest my voice a little bit, then I'll come back and we will take a stab at making a nicer multi-select on the inspector. Alrighty, I'm back. Yeah. Ugh. And let's do some music. Da-da-da-da. Just a little though. All right. Cool. All right, so we've got rotations and things working pretty well. Which one's this one? That one. However, we are still using the not a number hack to mark whenever we have a field that's not. To mark whenever we have a field that doesn't agree with the other fields. So we should start by looking into a better way to do that. I guess let's take a look at the DRI and GUI examples again. When we were looking through this before, I didn't see an obvious way to handle this, but maybe I just didn't look hard enough. So underneath widgets, selectables, no, not selectables. Just list boxes, combo boxes, color picker widgets. Drag slider flags. Drag float. Not really sure what that's about. Range widgets, maybe? These are just sliders that set their minimum value to be the value of the other box and vice versa for the maximum. Data types, drag slider, input slider. Multi-component widgets. So the multi-component widgets is where I got the original input float 3. I just plugged in one of these and it worked out of the box. I can change it to text entry if I want. Maybe I've been thinking about this wrong. Maybe I should be considering doing it the way that Unity does it. Because in Unity, they don't actually let you click and drag inside the box. They have you click and drag on the text, and then you just click in here to type into the box. Hey Jolo, welcome back. I'm fishing in IMGUI. Yeah, I'm fishing in IMGUI for better ways to do the visual on the transform box. And I'm thinking I'll either have to... I'm thinking I might have to do something custom. I like the ability to be able to just type in a number, but I also want to be able to click and drag. The way that Unity does that is you click and drag on the letter. And they've also got this nice little thing where the first direction you move the mouse is the axis upon which you're going to be working. So if you start dragging right, then all of a sudden you're dragging between left and right. But if you start dragging up and down, then you're... Or is it just diagonal? Hang on a second. Left and right goes up and down, but up and down also goes up and down. Oh, okay, that's interesting. So it actually uses... Hang on. I think it uses a diagonal axis for determining the dragging. That's funny. Okay. So actually, if you go left or down or anywhere in between, then it'll go negative. That's interesting. I wonder... Okay, no, the X seems to be... Yeah, okay. However, I'm not sure that I'm a huge fan of that. There was a thing in Max MSP that I wanted to borrow for this. And it's starting to look like this is not a thing that I can do directly with IMGUI. I might need to program my own interface. Which isn't, out of the question, but... let me do a new Max MSP patcher. Max MSP is basically a visual programming environment for audio stuff, and I use it for things sometimes. Something that it has that I quite liked is this thing where you can click and drag up and down on a specific digit, and the speed at which your value increases or decreases is scaled by that digit. So you can see here that I'm clicking and dragging on the whole number, and it goes up by whole numbers. And then if I go down here, it'll go up and down by whichever digit I've clicked on. I guess for the game development environment, this isn't necessarily a good thing, because if you wanted to go really fast, but you didn't want to snap to degrees, then really need a USB-C hub. Running out of USB ports. I play around with how Unreal Engine does it. Got like 5 devices connected to your PC that don't need to be connected there. Yeah. I feel you, man. I generally don't use my USB ports for charging anything. I just use my USB ports on my computer for devices. If I need to charge a USB powered thing, I tend to just use a power brick. Though I do have a limited number of power bricks, so I still run into the same issue. Man, I'm really indecisive about what I want for the interface. I don't want this clamped thing that Unreal Engine's got. Because in Unreal Engine, when I go to change, let me move the outliner out, or the detailed panel out. If I go to change the value of like rotation, for example, wow, this thing is lagging. it'll clamp it to the 360-degree range, and it doesn't allow me to wrap around, and I think that's dumb. I think you should be able to just continually go in circles. It doesn't clamp on the position or scale, which is good. Wow, this is so laggy. Unreal Engine 5 on my computer. It's amazingly laggy. Just for this simple little scene. But I also kind of like the idea of clicking and dragging on the box to change the value. Surely there's got to be a combination box in IMGUI where you can click and drag and click to type. UE is really laggy on my machine. I seem to be able to move the camera around really fast, but the UI stuff seems to be going really slow. Like when I go to click and drag on it to change the position, like when I click and drag on the widget, it works really, really fast. But, well, it works mostly fast. Yeah, and I don't even know what's happening there. That's a combination you haven't heard yet. Well, it's what we see here in Unreal Engine. You click and drag to change the value by dragging, and then you just single click and then you're typing. That works pretty well. It's pretty. I don't know. It seems pretty nice, but it's a little hard for me to gauge because it keeps lagging while I play with it. Even with this like super simple scene. What did they do to UE5? What did they do to my boy? Yeah, I don't know. I like Unreal Engine for a lot of things, but it's also like it's got so much overhead for an engine. Like I can play on a lot of Unreal Engine games on my PC, even though it's a really dated machine. But like using its tools, like they like pretty much count on you having a high-performing PC if you want to use the editor, and it's annoying. I mean, all I'm doing is I'm dragging a guy around, right? And it's lagging. Yeah. Yeah, and it straight up hangs sometimes too. Yeah. I'm done with that for now. I wonder if I could do if I did like a normal text box. I still make anything on UE5 because I still don't make anything on UE5 because I'm too bad at it. Yeah, it's it's like all tools, you have to get used to it. Hopefully, whoever makes your tools thinks long and hard about the ergonomic experience when they're designing the UI. But to be frank, there's a lot of times where you just kind of have to learn how the tool does it and then work against it if it works against you. But I was just thinking, what if I did a regular text box like this, but then I had a invisible button above it that if you click and drag on the invisible button, it takes focus away and lets you use the mouse delta to change the value in the box. That might be something. And a benefit there is that I don't just have to do float text only. Let me pull this up in the code. Let me pull this up in the IMGUI stuff. KW, close all. I looked at Cython, pretty cool, but very complicated. I don't think I've heard of Cython. What's Cython? Is that a game engine? It's a Python library that, it generates C++ code from your Python code. That's interesting. Yeah, that's interesting that it does a compilation of your Python code into C++. Subject to to the optimizer. That's pretty cool. Were you looking at it as like a tool that you can use, or were you looking at were you studying its source code? As a tool, yeah. It sounds pretty neat. The probably is not as easy to ship around on computers, right? Cython can also run C++ code in your Python file. Yeah, that makes sense, because if you're unless you mean to run it directly from a ran Python file. So not one that was compiled into C++. Is that what you mean? Because otherwise, you're just basically using a wrapper around C++. So you can plug in any C++ code. Directly to Python file. That's pretty cool. Yeah. I know that Python has commands that allows you to invoke other applications, but if there's a Python command that you type out your C++ code and then the library will automatically compile that and then run it, or translate it to Python from C++ or something. That's interesting. That's an interesting. It's an interesting tool for sure. I'm not sure. I'm not sure how I would use it, but I'm sure there's situations where it applies. I mean, surely if you write C++ code in your Python file, like surely that still has to compile, right? Is it like just-in-time compilation? Does it JIT compile when you go to execute your script, or does it have to go through a compilation phase? How am I supposed to know? Well, it would change how you use it, is how you would know. So a JIT compiler means that it compiles while you're running the thing. So, for example, if you're running a Unity game, it doesn't actually compile into machine language or assembly language or whatever. Into machine code when you go to compile. It compiles into an intermediate language, and then that gets compiled on the user's machine as it's needed. So that compilation happens at runtime. In the case of this tool, you would know because if it's pre-compiled, you have to wait for it to compile before you can run your Python script. If it's just-in-time compiled, then you can do a Python script that contains C++ code, and then you just run it, and then it just runs. Then it's JIT. Yeah, it's interesting. I would imagine that would add some overhead to your program, but apparently it's useful because somebody made a tool out of it. JIT's an interesting topic, just-in-time compilation. I'm generally not a huge fan of JIT. But there are some situations where it is helpful. So for the sake of portability, sometimes JIT is helpful at generating optimized code because the JIT compiler can make certain changes to or certain optimizations that are not visible to your compiler when you are working on your machine per platform. But it's there's a lot of people who love it. There's a lot of people who hate it. Don't want to compile the code every time I change something. Yeah, but I mean, like, that's the thing though about JIT is that you aren't avoiding compilation. It just takes longer to execute your program in general because it actually has to do the compilation while you're running your application, and then if the code's not ready by the time you go to run it, then you might experience a hang. Yeah, as a precompile. Yeah, it's it depends on the situation. Like if you have a very bad structure for your C++ is kind of notorious for this with the SDL. Like if you have a structure that's like hard to compile together, like too many files depending on each other and things like that, and then compilation takes forever because of that, then yeah, you can get annoying. And C++ is famous for programmers like bloating the compilation chain to like make it so like you're working in a structure that just takes forever to compile, and so like there's ways to get around to try and shorten the compilation time. One of which is compiling your headers into a precompiled header, or things like that. But yeah, like it's precompilation in general, I don't think is so bad as long as you're doing it in a way that it doesn't actually get in your way. Once we've got the editor to a certain period of doneness, for example, game developers will be able to just recompile only their game code, like in however many seconds it takes to do that, and then not have to even relaunch the editor. But in order to make that performant, I'll have to do quite a bit of planning. The final product is obviously going to be precompiled, but I hate waiting for the compiler to finish. Yeah, it's one of the one of the worst things about being a programmer is having to wait for your compiler to tell you whether everything's working. In game development, it's very popular nowadays to come up with a way to recompile and reload on the fly. And we're almost set up for that in this engine. So that way you don't have to recompile anything big and expensive. You just have to recompile your game code. And I've thought about maybe coming up with a situation where each individual CPP file can be hot reloaded, but that might be too complicated for my first outing. I tell you what, I'm gonna have to call this a stream. I'm getting nothing done. I've got the stuff that I wanted to do earlier is mostly ready. Just getting the rotations to work correctly, to have those be stored in the scene file, and we are now bypassing the all the stupid abstraction stuff I had to do with getters and setters before I did that giant refactor. That refactor is already helping quite a lot. But yeah, I'll need to do research on the IM GUI side, come up with a better experience for using this header or using this transform section, because right now the whole not a number thing is not very helpful. It does its job, but yeah. All right, take it easy, Joel. Thanks for popping in.